You want to understand relations, dependent and independent variables. For an equation in variable x and y, if the value y depends on the value of x, then y is dependent variable and x is independent variable. For equation variables x and y, if the value of y depends on the value of x, then y is dependent variable and x is independent variable. So in this case, a relation may be defined in several different ways. The relation may be defined as a set of order pair, like in this case here we have a set of order pairs. The relation may be defined as a correspondence of mapping. The relation may be defined as a table, as a graph, as an equation. So if I have y is equal to 2x, in this equation y is equal to 2x, the value of y is dependent of x. So therefore, the value of y is a dependent variable and value of x is independent variable. So it means that if I substitute for x any number, if I substitute for x, let's say 0, 0 times 2, that would be the value for y, which is in this case its corresponding value. So in this doesn't correspond to this table here. This is just another example of a relation. It could be any relation here. But we can write it as an order pair. So the first columns here correspond to the x, and the second columns in the order pair correspond to the y. So this would have different set of order pair for this relation. So domain and range for every relation defined by a set of order pair x and y, there are two important set of elements. The set of all values of the independent variable x is called the domain, and for the range would be for y. So when you're talking about the domain, we're talking about the value of x on the x-axis. That's what we look for. When we talk about the range, we look at the values on the y-axis. So give the domain and the range of the relation correspond by the table below. So in this case, the domain would be the value of x. So if I want to list them, would be 0, 1, 2, 3, 4. This would be my domain. And the range would be the value of y. 0, 3.5, 7, 10.5, 14. So these would be the value of the range. So give the domain and range of this relation. When you look at the graph, anybody know what is this graph of what function is that, by the way? We're going to get into graph of different functions. I'm just curious if anybody knows. This would be the absolute value. If a graph of absolute value looks like that. We're going to talk about that later. But let's say we have this graph in front of us. We want to find the domain. Remember, the domain was the value of x. So you look at the x-axis, and you can see if any values are restricted for x. Is it? This line here is going to increase and go all the way to negative infinity, right? And this line here is going to increase and go all the way, covers all the numbers on the negative infinity on the x-axis. So there's no restrictions here. So the domain would be all real numbers. So I can write as the interval notation. Domain would be all the numbers from negative infinity to positive infinity. However, there are some restrictions for the range. Do I get any value for y equals to 5? No. There's nothing exists on this graph when y is equal to 5. So the graph starts right at y is equal to 4 and down. So the range would be all the number from 4 all the way to negative infinity. That's how you can look at the range by looking at the graph. Let's take a look at another example here. Make sure we clearly understand what we're talking about. I'm gonna graph another few more graphs here. So if I have, looks like a parabola this way, going up and up this way. So this is a parabola, and this is 0. Can somebody tell me what is the domain for this function? What is domain? Okay, I want more than one student participate. Anyone else? Domain. Do I get any other check mark? Well, this is very similar to this, right? Remember, the domain would be the value of x, right? Anybody can tell me what's the domain for this function? Kind of similar to that. Can you put the check mark in front of your name if you know it? And yeah, negative infinity to same, right? Because again, this is going to go all the way, cover negative infinity, it's going to go all the way to cover positive infinity. So the domain would be exactly the same as this one. The domain would be all the numbers from negative infinity to positive infinity. How about the range? Can somebody put a check mark for every name if you know what range is? This should be easy, right? Any check marks? Range. What's the range? You can have a test to Friday, right? Okay, just start it. Yeah, so you're right. So in this case, would be the range would be all the number from 0 all the way to infinity, right? That is your range. The range would be all the number from 0 to positive infinity, right? If I move my parabola up here to 2, can somebody tell me what's the domain here? What's the domain? Did I mention you get credit for participation? Okay, Lopez. Yeah, the domain would be again from very good negative infinity to positive infinity. Okay, what would be the range? Very good. The range would be from 2 all the way to infinity. And just by looking at the graph, we can find the range and domain that way.